Hi guys, Mr. Bennett here again. Today we're just going to go through the concept of acceleration, and I'm just going to finish that PowerPoint off from the other day. So let's just go through that straight away. Now, when we start talking about acceleration, you already know about that because you've been in a car where you've seen and felt and experienced acceleration. So the definition of acceleration is the object change in velocity by dividing by the time. All right. So if you think about that, speeding up, slowing down. All right. So and I'll show you the formulas that we'll use later on. But if you understand that, that's the key concept. All right. So you need to be able to do that. Acceleration applies to decrease and increasing speeds. All right. So obviously, if you're braking, then you're decreasing your speed. If you're putting your foot on the accelerator, then you're accelerating and getting faster. So if a car is accelerating whenever it's changing its state of motion, all right. So if it's travelling at constant velocity, then it's not accelerating. It's got zero acceleration, all right. So when it changes its state of motion, when you put your foot on the pedal on the gas, as Americans might say, then you are accelerating, all right. So looking at this car here. Right, so change in direction is also an acceleration. So if you're travelling at constant speed, but you're changing the direction, in other words, the velocity is changing, then you are in fact accelerating. Right, so remember the example we talked about with a car going around the circle? Well, that's got acceleration. Right, acceleration is the direction of the velocity speeding up or speeding down. All right. So obviously this one here it's speeding up, so the acceleration is in the direction of the velocity, and this one's slowing down, so it's the acceleration is in the opposite direction, and this one's going off a cliff, so the acceleration is downwards. All right, so you get the idea. So the change in speed, right, over time interval, or change in velocity is really what we want to use as the term. All right. So let's go to the next bit. So speed and velocity are measured in units of meters per second, right, or kilometers per hour. Right, so we can look at, say, if you change your acceleration from 10 meters by 10 kilometers per hour in 1 second, then that's what the units are going to be, 10 kilometers per hour per second. That doesn't really make sense. We need to be using obviously compatible units, really. All right. So here's probably more of an example that you need to better do. Suppose a car's moving in a straight line, steadily increasing its speed each second, first from 35 to 40, and then from 40 to 45, and then from 45 to 50. What's the acceleration? Well, for every second it's increasing by 5 kilometers per hour, isn't it? So therefore, it's increasing by 5 kilometers per hour per second. I really don't like that, but we'll continue on. Right, so in 5 seconds, a car moving in a straight line increases its speed from 50 kilometres to 65 kilometres, while a truck going from rest to 15 kilometres in a straight line, which undergoes a greater acceleration. So what is the acceleration of each of the vehicles? Right, so both of them are changing their speed by 15 kilometres per hour, aren't they? Right, in 5 seconds. So wouldn't they all be doing the same? Right. So they're both experiencing the same acceleration. Right? Obviously, one's starting from rest, the other one's already moving, and that's okay. So how do you calculate acceleration? Well, so when we start looking at things like free fall, we know gravity acts downwards at 10 meters per second, or 9.8. So for a lot of the time, you'll say 10 meters per second squared. So objects that are free falling, right, we can look at them how gravity acts on them. So an object moving under the influence of only the gravitational force is what we call in free fall. So the time elapsed basically will tell you what position it will have and also what velocity it's going to have. So the acceleration is going to be the change in the speed over the time interval. So if you think after 1 second, it's going to be obviously, we know it's going to accelerate at 10 meters per second, right? So that would tell us what we're doing here. Right, so we should be able to actually work out how fast something is actually free falling. I'll just flip through to the diagram that's got that. Right, so we should better work out how fast this rock is actually falling, in terms of the time. So the free fall object, instantaneous speed after at the initial start will be 0. After 1 second will be going 10. After 2 seconds will be going 20. And so on and so on. Okay, it's increasing by 10 meters per second every second. So the average speed, obviously, is something you could work out. We're not going to do that here, right? Obviously, when objects get thrown upwards, they also undergo deceleration initially through gravity, and then once they get to the top, they'll accelerate. So I'll just show you an example of this. So if we've got a ball being thrown or a rock being thrown up, it might start off with a velocity of 30 meters per second. After 1 second, it's going to be going 20 meters per second. After 2 seconds, 10 meters per second. After 3 seconds, it will be stationary. After 4 seconds, it will go 10. 5 will go 20. After 6 seconds, it will go 30. After 7 seconds, it will be moving 40 meters per second. So these ones are going upwards and these ones are going downwards. The velocity will be in different directions. The acceleration is always acting downwards at 10 meters per second in this particular case. Alright? I think we'll just leave that there in terms of the concept. So the key concept of acceleration is the change in velocity over the time period. Alright? And we'll show you how that relates to some formulas in my next video. Alright, I'll talk to you in class. Bye.